Ashley, you're back.
Yeah, I'm trying to take advantage of this.
Dude, I'm so happy. I'm so happy it's you. I
Oh,
saw your
really?
name on the list and I was like, sweet,
Oh,
maybe
well,
Ashley will come back.
are you always doing them or is it somebody
Lately, I
random?
seem to be the one, but usually it's other people. I don't know why I fell into two in a row like this. This is really rare for me. So
Oh,
so
okay.
sorry though if you're expecting someone else.
No,
Just
it's
me,
okay.
I'm afraid.
I just saw you speak too at the GMAT day on Saturday.
Oh yeah,
Um,
that's true.
I
I
seen
did.
you. Yeah, that was interesting because I was like, I guess it was just a way for all these different uh like educational services to promote their
I guess
thing, right?
so.
Yeah.
Yeah, exactly.
So
I get a note like, "Hey, do you want to do this?" I'm like,
yeah.
"Sure, I'll talk about this." But yeah, in the end, it's just like
So
GMAT Club
yeah,
promoting all of us and all of us
it wasn't
promoting
really
GMAT
like
Club.
I mean, I like the yeah. I mean, your session was good because you went through like a few problems and stuff. But otherwise, I was like, well, I kind of already know where I'm gonna go, and I know like
Yeah.
what I want to use. I don't know. None of the other resources really convinced me. None of the other companies really convinced me. Like, I think if I'm
Yeah.
gonna pay, I'm gonna go with Manhattan Prep. So
Well, well, then I
yeah,
guess GMAT Day did its job.
but I already knew that going into it. Like,
It's
I was
true,
like, I don't know if
exactly.
anyone else is better.
Nothing changed.
Yeah, nothing
Um,
changed. I was right.
yeah, either way. Look, I'm happy you were there. I'm happy you're here, though. That sounds like a lot of, Ryan Star in your life in the course of 2 weeks. So for that, I
You
apologize.
know, you have the same name as someone who was on American Idol.
Dude,
Like,
do I
okay.
ever? Yes, I do. And it turns out it's not even her real name. Her name's like Tiffany or something. And she just thought,
Yeah.
what would be a cool name? Ryan Star. And like, I'll take it. Like,
So it's
I
not
did
like,
get a lot of like, whoa, like on American Idol around those years.
yeah,
Yeah.
that's so funny. Aren't you glad the early 2000s are over? Because she was on like the surreal life and stuff. She was like out there for a
I know,
bit.
I know. She was out
Yeah.
there for a while, right? She was showing up all over cable TV. It's true. I always wished her well. I always kind of wished like she would win and then there'd be one famous Ryan star out there. But she tried her best. She tried harder than I did, that's for sure.
Because
Um,
I was like, is that Ryan Star? I don't know. When I saw your name, I Googled it and then
I know how cool would that
yeah.
have been though? It was like, yeah, it's an American Idol contestant with some pull, and on the side, I just teach GMAT.
Yeah, that's
I like
pretty
huge
awesome.
respect to her if she could do that. But like respect her anyway, 'cause she can sing. That is one of the great talents, I think.
Yeah.
Yeah, so but you're here and I'm here, and it seems like nobody else is coming this time.
Oh,
We miss
sweet.
you, Priyanka. So you get to kind of run the show again. Like last time I came happy to talk about overlapping sets or whatever, emphasis on whatever. What's been on your mind since we last
Yeah.
spoke?
So I did another practice, uh, and I improved my score by like 15 points, which isn't great, I think. Um,
But
but I
it's
guess
not
like
like bad.
that's not
Yeah.
bad after
But it's
3 weeks.
yeah, it's not look, it's not the kind of improvement you'd want to see, right? But
Yeah,
improvement is improvement. But yeah, I understand.
yeah. And
Um, what
I think
did it feel different qualitatively? Like, did it feel different as you were taking it? Was there any kind of like soft skill improvement in it that you
yeah.
could see? Did you expect it to come out better than that? Like,
Well, I think like yeah, I think I expected it to be better. My quant like did jump a bit. Like it was like I think it was 67 the first time,
yeah,
and then it went up to 74.
okay, all right, good.
So that was a good improvement. And then I guess like the other ones didn't. Verbal was still the same. I think I improved like one point there,
Hmm.
like 81 to 82, and then DI. But like I hadn't been focusing on those areas. Like I've been
Yeah.
just focusing on quant.
Right.
So
Okay. So it
that's
told like,
yeah.
look, I would say a 7 point jump even in 3 weeks of studying is like it's a good jump on quant. I know it puts
Really?
you, yeah, no, like it
Yeah.
definitely. It's like quant points are pretty hard fought points nowadays. Like the test
Right.
is punishing in quant much more than even it used to be. Because it used to be that the quant questions felt just as hard as they do now, but you could miss
Huh.
like 10 of them maybe and still get a pretty high score on the section, right? And now it's like you miss 5 of them and you're pretty low down. And so yeah, like
I see.
it's a battle, that quant section. So like at 74 right now, you're still a little bit under the mean score, I think, right? But you're getting like much closer to it and good. And I think like once you're past the mean score, which like look, if you were to continue on your current trajectory, which I don't think is necessarily going to be the case, but if you were to, 3 weeks from now, you'd be at about an 81 and you'd be like well
Right.
above the mean and you'd be in like great quant score territory. So like, no, it's a good jump and like
Mean.
it's good to hear
Uh,
that the mean, I want to say it's like 77-ish or something like that.
77. Okay.
Yeah, yeah. It's always changing a little bit as more data comes
Right.
in, and I haven't looked at it like super lately, but 77-ish is about right.
Okay.
Yeah.
And I think I looked at like what the area, like what specific quant
Hmm.
areas I didn't do. So it was inequalities was a big
Yep.
one.
Yep.
And what's the other one? Inequalities, uh, and ratio and value/order. Uh, yeah, those three areas.
Value slash order. The most, the
Yeah.
clearest of all the topics, of
Value slash
course.
order slash
Value slash
factors.
order.
Yeah.
Yeah, value order factors. I know the one.
Yeah.
So value order factors, just to give you an idea of what that actually breaks down to, is largely speaking arithmetic stuff.
Arithmetic. Okay.
Arithmetic stuff, like if they say, there's one, on the easier side question in the official guide that's like, which of the following fractions is closest to 1/2? That would be a value order factors question. Factors, of course, implies divisibility, right?
Right. Okay.
And so divisibility is in there. Order is another way of talking about like exponents and roots and stuff like that. And exponents,
Okay.
exponents are like terrible because they can show up anywhere. They can show up, with very algebraic setups. They can show up with very numerical setups. They can show up in divisibility problems, positives, negatives problems have them a lot, odds and evens problems. Like they get their fingers into every pie. They can show up in inequalities problems too. And so like it's weird to have a category for exponents because honestly, exponents could show up everywhere and you're going to see them
Okay.
like a few times on any given test. But certainly for those more like pure exponent problems, that's what order would cover. So yeah, that kind of stuff. And you said, sorry, now I've gotten so caught up in value order factors, I've forgotten the other two were inequalities
Inequalities
and
and ratios,
rates.
which I kind of
Oh yeah,
knew. Yeah.
yeah, yeah. That makes sense. How did you know, by the way?
How did I know that those were my
Yeah,
areas? I just
yeah.
looked at the breakdown.
No, no,
of,
no. I mean, you said you kind of knew that ratios were a thing, right? How
oh
did you
yeah,
know that one specific?
just from doing the practice questions. I
Gotcha.
was like, I don't remember how to deal with yeah, inequalities like every time like I can like I think my arithmetic's okay. Like maybe I
Yeah.
just need like algebra. Like maybe I just need a refresher on that. But I am enrolled in that free GMAT that free what's it called, the math course. That's
Yeah,
like
the
5 hours.
foundations.
Yeah,
Yeah, yeah, the
foundations. Like
Saturday
I'm gonna
class. Yeah,
take that.
yeah.
Even though according to the Manhattan Prep diagnostic thing, I don't need it, but I'm gonna take it. But you
Yeah,
yeah.
you might as well. It's like it's a
Yeah.
free class. And that one's not taught by me. That's usually like Whitney or somebody else. So
Yeah.
so
I
you'll
think it's
get all of it.
Damien or something. Can't
Oh,
remember his name.
exciting.
Yeah.
Yeah, it might be
Yeah.
like a Dimitri, it might be a
Dimitri,
like
yeah.
yeah. Yeah, he's a good one. He's a lot of fun. So yeah, that'll be good. All right,
Yeah.
all right, that's exciting.
So I'm doing that to kind of brush up on because it's like it's weird. It's one of those things where like if you haven't done it in a long time, you're like, I think I know this is right, but I'm not really sure
Yep.
with certain things, like certain operations and stuff. But
Hmm.
yeah, but like inequalities and yeah, ratios, I think I just never I don't remember when I learned that. But
Yeah,
it's been a
that's
while.
fair.
Yeah.
That's 100% fair.
Yeah.
Okay, so let's talk about at least a couple of those topics. Inequality and ratios are good ones.
Mhm.
Also, we've been joined by SA. I feel like I've seen SA around. I feel like I've seen you around, SA. Where are you at with things? What brought you here? What are you kind of most concerned with? Because we got inequalities absolutely on the list. I've got one ready to go. I'm so excited for us. But yeah, like if there's anything about you here, you can take the mic, you can tell us in chat. Um,
Yeah,
and
hey.
hey,
Um, I don't have anything particular. I just kind of wanted to test the flavor of the course, what was going on.
nice, nice, perfect. All right, well, welcome. You're here
Thanks.
now. I promise they're not all like this. Ashley can tell you. But so this is our like free prep hour, and basically what tends to happen is if we have like a few people show up, I'll go through something I was planning on doing, and you guys all get to just come along for the ride. But lately it's been like one, maybe two people showing up, and so it's been more like, hey, what's been giving you trouble lately? And let's focus on that for a little bit. And so Ashley was here. and telling me that there was trouble with inequalities, ratios, and then the value order factors category. So we're going to see some problems that touch on a few of those things. And yeah, that's the plan. It's really nice to have you here as well. All right. So inequalities, the thing about them is they're not so different from equations, right? You can do a lot of algebra on inequality setups that you would on equation setups if you kind of like pretend the inequality sign was an equal sign, right? Add the same thing to both sides, or like move things from one side to the other in the same ways that you can generally do algebra, right? The big difference with inequalities versus equations is what? Do you guys know? It is negatives. So quick like primer on that. The whole idea with inequalities is you can add or subtract whatever you want to both sides. Like adding and subtracting, they come free. There's never a worry about that. In that way, they are exactly like equations. So if you have like, x plus 3 is greater than 9, and you want to know about x, just like it was an equal sign, you'd move the 3 over, you'd get x is greater than 6, right? Same exact operation, and it doesn't matter whether you're like subtracting 3 over to the other side, adding 3 to the other side. It doesn't matter whether it's a positive 3 or a negative 3 that you're starting with. With adding and subtracting, anything goes in inequalities, right? So add or subtract at will is basically the rule for inequalities. If it's numbers, if it's variables, it just doesn't matter. Where inequalities get complicated and where they differ from equations is where positives and negatives get concerned, and specifically with multiplying by or dividing by negative numbers. All right, so multiplying or dividing by a positive is also just like in an equation. All right, you can, if you have like 2x is less than 20, let's say, divide. You have 2x is less than 20, and solve for x to get it by itself because it's attached to the 2 by multiplication. You divide over it to the other side. That's fine. Nothing changes. X is less than 10. And you can kind of test it. And that's one thing, by the way, Ashley, I want you to like absolutely keep in mind about inequalities. When in doubt, just test numbers, test the answer choices. Like a lot of the same kinds of approaches that work on vastly different problems still transfer over to inequalities. All right. Like, if you get an answer like x is less than 10, you should be able to plug 9 into the original thing and have it come out true. And indeed, 2 times 9, 18, is less than 20, right? So that checks out. But if you're dividing by a -2, then things get a little more complicated. And they get a little more complicated because of what happens when you multiply by negatives in general, right? If you're multiplying x by -2, then the bigger x gets, the greater x gets on the number line, right? The smaller that product gets, right? If x is like, 5, then cool, -2 times 5 is -10. That's like fairly small. But if x is like 5,000, now that -2 multiplying by it is going to turn the product into a -10,000. So the bigger x gets, it's like that negative corrupts it almost, right? It's going to take whatever's great about x and turn it negative. And so to reflect that weird phenomenon whereby actually as x gets bigger, -2x gets smaller, which is a really relevant thing to think about in an inequalities context, because inequalities are all about what's bigger or smaller, right? What's greater or less. To reflect that, what happens with negatives is this. If you divide a negative or multiply a negative over to the other side of an inequality, you have to flip this inequality sign. And basically, like most inequality problems you see on the test are going to be in some way built around this property of inequalities. The fact that inequalities are weird when it comes to negatives. All right. You have to think about something with them you don't have to think about in an equations context. I'd say maybe half of them. The other half will just be about the fact that inequalities are like ranges, they're uncertain values, right? But half of them will be about the negative stuff. And especially when they're more abstract like this, they have more variables in them and stuff like that, you really think about the negatives. Some inequalities problems, they'll tell you all the variables are positive, and they're telling you in that case, you can do algebra, don't worry about the negatives, but A lot of inequality problems are about this. So that means that this one comes out to x on the left, right, -5 on the right, but it has to be that x is greater than -5 for this to work rather than less. And again, if you test values consistent with this, it checks out, right? Like 0 is greater than -5. -2 times 0, that's 0. That is less than 10, right? So this like holds true. But it's because also if x were less than -5, then it's a negative number, a bigger negative number, a bigger negative number. And when that gets multiplied by -2, the product gets overwhelmingly positive, right? So you'll end up violating the inequality. So this is kind of the big thing with inequalities. You multiply or divide both sides by a negative, you flip the sign. For my part, I just do it as its own step. I don't even divide by a -2 because I mess up negatives. Like that's one of my Achilles heels. So I'll just like say, you know what, let me change the sign on everything there, and then I can divide by +2. And you get to the same place. It's one extra step, but it's a step that keeps me safe. Now, where the GMAT gets trickier with it is where variables are involved, right? Because variables are kind of by their nature ambiguous. So if you have something like xy is greater than xz, if this were an equation, you would think very seriously about dividing both sides by x to cancel it out. Now, there's one caveat to that, even if it's an equation, and that is x could be 0, and you don't want to divide by 0 under any circumstances. But if they've told you x isn't 0 or something like that, you divide both sides by x, it would cancel out, right? Like that's kind of the like term here. If you're in an inequalities context, though, even if they've told you x is not equal to 0, so let's start under that condition. That means x is guaranteed either to be a positive or a negative number. It's not equal to 0. You can't divide by the x. Because if x is a positive number, then dividing by the x, it'll cancel it from both sides. Dividing by the x would leave the inequality sign exactly as it is, right? No flip. But if x represents a negative number, if the real value of x was like, -5, and we just didn't know at the time, then we'd have to still flip the inequality sign when we're dividing by x, because x is just a stand-in letter, but for a negative number, right? And it's going to behave like negative numbers behave when it joins other stuff. So when you're not told the sign of a variable in an inequalities problem, often they're going to try to tempt you to do something like this, and you just don't do it because you can't do it responsibly without knowing the sign of the number that variable represents. However, what they will do in a lot of such problems, I touched on this a minute ago, is instead of telling you x is not equal to 0, they'll tell you something like x is greater than 0. And if they tell you that, then you algebra at will. Then you can absolutely say y is greater than z. In some rare cases, they might tell you x is negative, and then you could do the opposite. You could divide by x and then say for sure y is less than z. But you don't know x's sign. You can't pull any of that. All right. Question. Talk to me. Good. Good. And the same goes for multiplication. So if you have like 3 over x is greater than 5 over x cubed or something, and you might be inclined to multiply both sides by x cubed. You don't know x's sign, you cannot do it. You cannot do it. You can multiply both sides by x squared if you want to, because x squared, if it's not 0, is going to be a positive number. Anything to an even power going to be a positive number. This is one of those ways, actually, that exponents get involved in everything.
Okay.
Yeah, but basically, this is the big thing with inequalities on kind of an abstract level, that they're going to hinge a lot on whether the values you're working with are positive, negative, or you don't know. And when you don't know, you've got to be the most cautious. All right. So
I just had a quick question.
ask it, please.
If there's an event where you don't know and they don't sort of give you an x greater than or less than 0,
Yep.
that just an answer choice you don't choose because it's too risky?
It's more likely that this would be in the setup of the problem, and they'd give you something else about x, or they'd say like which of the following must be true or something like that. And it might depend on where they go from there, but they'll say maybe something like, give you statements in the answers, like if X is less than 0, then Y is greater than Z or something. And you'd be able to say, oh yeah, that's not true, because if X is less than 0, Y would be less than Z. And like, they might give you something like that, or they might give you another fact in the problem, like X plus Y is equal to 9, and see what you can do with it, or just something along those lines. So this would be like just a piece of a larger problem, but it would more likely be in the problem thing. And then when combined with other things they give you in the problem, you can make some sense of it. Like, I mean, this problem we actually have here is a kind of decent example of that, right? I mean, I guess not, because they tell you these things are greater than 0, but they're expressions. But like, yeah, they give you some other things in the problem to work with. Or maybe this would be like the question stem in a data sufficiency question. They'd say, is XY greater than XZ? And then in statement 1, they say X is, whatever, X is equal to 3, X is less than 0, or just something like that. They'd have to like supply some more info basically for you to work with it, but they would solve the problem.
So regarding, okay, so that
Mm-hmm.
example,
Mm-hmm.
XY is greater than XZ.
Mm-hmm.
If you divide by, okay, so if you're assuming X is positive,
Mm-hmm.
then it is Y, when you simplify, it's Y greater than Z. But then if you're saying X could be negative, and then you divide by negative X on both sides, and then you flip it, and then wouldn't that be Z is greater than Y?
Yeah, exactly. Which is
So
why.
that's,
So basically, I was saying,
yeah,
like, if they don't tell you about X,
yeah,
X's sign, you don't do it because you don't know which way it's going to turn out, right? It's ambiguous,
okay,
and your hands are tied in that case. It's
right,
only if they tell you, like, somewhere else in the problem, X is positive, or if they get at it some other way, or X is
yeah.
negative, then you can pull some algebra on that, but only if they've told you in some way that X is positive or negative. And usually it'll be positive if they're going to do it like that. So
Because then in
yeah,
that case, you have two ends that are like contradictory, so you don't have a solution,
you see, you don't
or
have it.
like,
So
yeah,
exactly,
yeah,
because you don't. So that's like the big thing. If you don't know X's sign, you don't have any way to move forward. You don't have it. Like,
right,
it's already kind of in its most simplified form. I mean, to be fair, look, if I'm being totally honest, there's a thing you could do, and it might depend very much, to SA's point, on the context of the problem, right? But you could, for instance, subtract the XZ over and say, oops,
yeah,
that's positive, and then have it as x times y minus z is positive, but like, you wouldn't even do that necessarily unless again, maybe it's data sufficiency, right? And they're asking this as a question, and then if you break it down this way, maybe one of the statements tells you y minus z is greater than 0 or something. And so having it in this form would make that statement resonate a whole lot better. It would help you to see that statement's relevance to the original question. So I don't want to say that there's like nothing at all you can do with it. There's like,
mhm,
reorganizations you can do with it. But whether you would or not, it very much depends on what else is in the problem. Kind of to like what I was saying on Saturday, that like, this whole problem is like, how do you web your expectations from this thing with your expectations from that thing, and like, join them up into an actual approach to a problem. And so you'd absolutely be looking to other things in the problem to give you a hint as to what to do with
right.
something like this if you didn't know X's or Y's or Z's sign.
Okay, here's a silly algebra
No,
question because I
please.
just realized I might not know how to do this. So
Uh-huh.
for that example you gave with 3/x
Yeah.
is greater than 5/x cubed, and then you
Hmm.
said like if you multiply each side by x squared,
Yeah.
how does that simplify then?
Oh,
What does
it
that
doesn't.
turn
It
into?
doesn't. I was saying more that, like, as a maybe interesting side note, because of this thing with positivity and negativity, x
Yeah.
squared and things like it have a special significance, because you can do more algebra with them even if you don't know x's sign, because they're going to be positive. Here, I don't know that it would simplify things. I mean, it might
I would,
simplify things a
yeah,
little bit, because like, look, you do it on both sides, and
right.
one, it takes away the fraction on that side. It makes this side just
Okay.
3x. And then
3x and
two,
then
it takes away the exponent on the other side is greater than 5 over
5
x.
over
And
x.
like, still, whether that's useful or not very much would depend on the wider context of the problem, right? Like, if I
Mhm.
see something about 3x elsewhere in the problem, then I know, hey, I could get there if I do x squared on both sides, and I know I'm allowed to, because x squared is not going to break the exponent or the inequalities rule, if that makes sense.
Okay.
So like, it would really depend on what else I was supposed to, like what other puzzle piece they gave me that I was supposed to fit 3 over x is greater than 5 over x cubed in with. Like that's what guides a lot of your algebraic manipulations. Where are you trying to get to, or what else in the problem are you trying to connect this thing with? Yeah.
I mostly asked that just because I wanted to make sure I was dealing with the exponents right. So when you multiply it, then you subtract the exponent, you end up with like I was like, is that right? I just wanted
Yeah.
yeah, okay.
That's what it is.
Yeah.
Yeah. Yeah. All right. All right. So now bringing it up to this problem. So one of the things then, because of that thing with inequalities, it's sometimes hard to read when you're looking at a problem, whether it's like meant to be an algebra focused inequalities problem or more of a positives negatives problem, like more of a number properties and conceptual type problem. Um, One of the ways you often know that it's more about positives negatives is like seeing greater than zero somewhere in the problem or less than zero, or seeing answer choices that are like differentiated by sign, right? Like you have u over v and u over minus v, things like that tend to hint at, oh, maybe positives and negatives are a thing. But you know, the presence of a lot of variables and stuff like that, and especially like them telling you that things are positive straight up in the original setup, that kind of pushes the other direction. So part of the difficulty with inequalities is they're a lot more ambiguous. You know, with like take rates problems for instance, you kind of like, you know, going into a rates problem, even if you're not expert at it, that, oh, this is one of those like distance problems, or no, this is one of those work problems. Like you can kind of tell the subcategories a bit more easily, I think, there than you can in inequalities problems, because a lot of the positive negative problems, they look like algebra problems. It's just that your hands are tied algebraically. And so like what tends to make the difference is honestly, if you have a lot of variables, this thing right here, have they given you a positive constraint? If so, it's probably an algebra problem. Have they not given you that constraint? If not, then you've at least got to be thinking positives, negatives alongside any algebra you might want to do, because it's more likely to be about signs. All right, that's kind of the long and short of it. That's one of the things that makes inequalities harder to deal with. And but on the bright side, I should say, it's also one of the things that means inequalities get involved with value order factors. So in rectifying some of the inequality issues, you might be rectifying some of the value order factor category issues as well. So coming back to this problem, they've told us that u and negative 3v are positive, right? That's always how you want to read greater than zero, positive. And that means that we're talking about the square root of some positive number being less than the square root of some other positive number. One thing worth unpacking is, how could it be that negative 3v is positive? Because it's got a minus sign right in front of it.
Yeah, I don't understand that. If v is greater than zero, that's still a negative number multiplied
Well,
by negative,
precisely
right?
that. So what does that actually then mean about v? Like you're putting your finger on it.
There's no solution, or
No, no.
there's no, I don't know.
This time there's absolutely a solution. And this is where, like, even though this is kind of telling you that things are positive in the beginning, this is partly a positives negatives problem as well. So you know that negative 3v is greater than zero, right? And if you do that thing that I talked about down here, where you just say, oh, negative something, I'm going to change the sign on everything in this problem. Like if you have a negative in front of the variable term, it's usually a good idea to. That makes this 3v is less than zero, or 3v is negative, right? Like if negative 3v is positive, then positive 3v must be negative. Essentially, like logically, it kind of makes sense. We're talking about the opposite of this thing, right? How could 3v be less than zero?
V has to be negative.
V has to be negative. So using rules of positives and negatives, if a product of two things comes out negative and one's positive, the other's got to be negative. They have to have different signs. Using rules of algebra, if the rules of positives and negatives fail you, at this point you can just divide by a positive 3, and that's positive. That doesn't change anything. And so you can also come algebraically to the fact that V itself must be a negative number. And that's likely to be important given that in the answer choices, you see that V and 3 or -3 are kind of getting separated from each other in some of the answer choices. And in some cases, V is getting divided over. And so knowing something about V's sign might well be an important thing. We know we can infer from what's there that, yeah, the only way -3V is greater than 0 is if that -3 is multiplying by another negative number. So V must be a negative number. And then they ask which of the following cannot be true, which means, like, which of the following questions it's worth taking a moment and saying, okay, what can I eliminate? 4 of these answers, the ones that you can eliminate, can be true. Only one of them cannot possibly be true. And usually, look, we've already got a bit of positives and negatives introduced, so that's going to be because of maybe a sign violation that one of the answers commits or something along those lines. Like one of these, you can tell that they're kind of algebraic rearrangements of the original, but one of them's probably going to break a rule of inequalities. And you can almost kind of like anticipate that because it took a little bit of work to figure out that V was negative, that maybe one of those is going to pretend V was positive, if that makes sense. So this is just like, this is, again, going back to what I was saying on Saturday, actually in that session, this is about like reading a problem the right way. The more you can kind of anticipate what's going to come, you can figure out like why they've given you something, the better. And the answer choices do help with that. The answer choices also tell you a couple of things. Like, look, of all the answer choices, I'd say this one looks the most like the original, right? It's kind of the most unchanged from the original in some way. Or maybe like this one down here. I think both of these have a play, right? Because both of them represent one change. But when you look at like the original up here with all its square roots versus the answer choices, one of the things that the answer choices are basically like screaming at you is square both sides. Like you should probably square both sides or get rid of those square roots, right? And so there's like kind of an algebraic pull on this problem as well, where like you can do a little bit of algebra on the original, it'll look a lot more like the answer choices, and then you can see about moving stuff around. Probably won't be the case for answer choice C, but for the other ones, yeah. Can you square both sides, you might wonder, in an inequality? The answer is yes, as long as you know both sides are positive. Because squaring is kind of like it's a shortcut to multiplication, but it's multiplicative. Squaring both sides and square rooting both sides are a little bit tricky if they tell you both sides are positive, which they have here. If u and -3v are positive, the square roots of them, they're always going to be positive. In fact, anytime the GMAT itself on the test on the screen writes a square root sign, the result's positive. And so you know both sides here are like guaranteed positive, and you can definitely square both sides. And so you also know that u is less than -3v even before you go to the answer choices, which means not only can E be true, E must be true. And that one can be eliminated at that point. But where can we go from there?
Can I say which one's jumping out at me
Yeah,
as
please.
wrong? Okay, I think A seems very wrong. Like it cannot be true to me. Um,
Because
because okay, so if U is less than -3V, and then you divide by -3 on each side, so then you have to flip that around, right? Uh, so then does that make it negative?
well,
I don't know.
here's a
No, okay.
counter question. Did they divide by -3 on both sides?
They just divide by 3, I guess, not -3.
They just divided by 3. Exactly right. And so
Okay.
no violation there, actually. That one's
Okay.
okay. Yeah, that one's okay because 3 was a positive number and they left the negative behind.
I guess
Um,
what's throwing me off is the negative in front of the V because we're saying V has to be less than 0.
V itself, so think of V as like any variable as kind of like a box. It's like a box holding a secret number in it, right? It's a closed box. You don't know what it is. But right now, we know enough about what's in that box, shaking it around a little, we know there's a negative number in there, right? Putting that minus sign in front of it basically just means the opposite of it, right? So if V represents, say, -5,
Right.
minus V will make it a +5 is all that that means.
Okay.
So that minus sign in front of it has nothing to do with whether the value contained in V itself is positive or negative. It's just going to take whatever that value is and change its sign basically to the other thing. And since we know v is negative here, we know that minus v will change it to a positive overall. You can, the way my algebra teacher taught it to me way back when in like middle school is you can think of a negative sign in front of a number or a variable as -1 times that thing. And that can sometimes help you like that negative is not really a part of v, it's acting on v essentially, or it's like it's a partner with v. So a should be okay. A should be something that can be true. B is a lot like it, but of course, instead of dividing by 3 to get to B, you can kind of, again, connecting the dots. See, we divided both sides by V. Yeah. Is that cool? Can we? What should happen? This is where it really comes into play, what we know about V from the question stem. Since V represents...
That looks okay.
It is okay, but this little fella here, he's going to have to flip. Because again, V, when you just are dividing by a letter, right? V looks positive because it's not got a minus sign in front of it. It looks like just a positive letter. But remember, it's not about the letter. It's about the number contained inside it, right? And what do we know about that number? We know it's a negative number because of what we figured out up here, essentially, right? We know it's a negative number. So if we're dividing both sides by V, we're dividing both sides by a negative number here. Which we can, like you can do it. If you know V sign is negative, like without ambiguity, you know it's negative. You can absolutely do that, but only if you flip the inequality, right? And that's what B says as well, right? It says, okay, yeah, but it's got to be greater than now, right, guys? And we're like, that's right, because V was a negative value. So little attention to detail, things like that. The fact that A and B have different inequality signs, they give you hints as to, again, what sort of stuff to think about. But making inferences up top whenever you can also gives you a big hint as to what to think about, right? Like I hadn't really even, I will be honest, I've not ever done this problem before. Like I wanted to choose one that would be fun for all of us. And so I was giving kind of my honest take on like, if I see V is negative up there, I'm thinking they're going to use that at some point, and B, answer choice B is at least one example of a place where they totally use that. But not as much as they do in answer choice C. How do we get to answer choice C? Algebraically speaking.
You divide by negative V and then you flip it. Is that what happened? And then square root.
So you divide it, yeah. So if you're on the kind of, you've already squared both sides, U is less than -3V. Yeah, you're dividing by -V in both cases. Now the question is, do you flip it when you divide by -V?
If you divide by a negative.
Well, no, so you do. So you flip it if you divide by a negative value is the way of thinking about it, right? By a negative value. And so if you're dividing by -V, remember, that's two things. That's a negative sign and it's whatever V is. But if V itself is negative, like if it represents a negative, then that negative sign in front of it makes the whole thing, the whole expression, positive again, right? Like let's say V was secretly -5, right? Which is possible because we know V is negative. Then if we have minus V out there, what that really means is we've got a minus -5 going on, right? And what happens with that? If we have a double negative right there like that, they disappear each other. Double negative will cancel out, right? Minus, minus. Again, another thing my middle school algebra teacher told us to do, change them both into pluses. She was from Texas. It made a lot of sense at the time. Either way, two negatives cancel each other out. And so when we divided both sides by V, we had to flip that inequality because V is a negative number, represents a negative number. But if we're dividing both sides by minus sign v, remember, that's like the opposite of v. That means minus sign, if v is a negative number, minus v is a positive number. And so this one doesn't need to be flipped. Weird. And like,
is that because it's a variable? Is that why? Like
it's
it doesn't need to be
because
flipped.
no, it's because it's a variable that we know represents a negative number. Like
Oh,
again,
okay.
pretend it was that v was actually -5. If we're dividing both sides by -5, we're dividing by +5. We're dividing by a positive value. So
Right.
not because it's a variable, but because rather we know that that variable represents a negative number from the work we did up here, from when they told us that -3v was positive, and we could infer, oh, well, that's only possible if v itself represents something negative. That's what made this maneuver okay, it turns out, or like made it so we didn't have to flip the sign on this maneuver. We know that v is a negative, so we know that negative v is a positive. It's like, it's trippy. It's a bit mind bendy. But like, yeah, you have to almost like think of v as something that, even though it just looks normal, could be negative, right? And is in this case negative. It represents a negative number. We don't know which one. We don't know if it's -1 or -5 or -100, but we know it represents something negative, and so we know with certainty minus v represents something positive. And then, as you say, yeah, you square root both sides. And so C is also very much something that must be true based on what they told us originally, just in a very trippy and unexpected way because of this -v thing, which only leaves D. But why? What's wrong with D? Yeah, no, our kind of clean version of this was U is less than -3V. Why is D something that just cannot be true?
Well, if you
Well,
square both sides, then you get u is less than -3v,
Hmm.
and then you bring it over.
Yeah.
But then that 0 is facing the wrong way, I guess.
Yeah, that's
Is that
exactly
why?
it. That is like
Yeah. Okay.
precisely the issue. And now my pen is being a weird dude. But yeah, no, that's exactly it. That it should be u plus 3v is less than 0, not greater than 0.
Yeah.
And so yeah, this one's, so D's the one. And notice it's the most subtle thing and the most inequalities thing of all. The sign is pointing the wrong way. And that's like, to some degree, that's a lot of inequalities problems in a nutshell. Like, it's always about that like inequality sign and what happens with positives and negatives and all that good stuff.
I think,
Can you go over B again? Because I feel like I
Mhm.
missed why that one is possible.
Yeah.
Because you have u is less than -3v, and then you
Hmm.
divide by v, so then you get u over v is less than negative. Yeah, is less
So,
than
but you're
negative.
dividing, both sides by something. And in an inequalities problem, when it's a variable, especially, you're asking yourself when you're doing that division, wait, what do I
Right.
know about the sign of V? Like, is V guaranteed positive here? Is it guaranteed negative, or do I not know? Right? Because
Right.
that governs your course of action. If it's guaranteed positive, you do it, you don't flip. If V is guaranteed negative, you do it, but you do flip the inequality sign. And if you don't know whether V represents a positive or a negative, you just don't do it. Right? Here, we know that V, and again, this all comes down to the fact that they told us -3V is greater than 0 up here, right? That -3V is a positive number. We know that V has to be a negative number. To make that rule work, to make -3V a positive number, V has to be a negative number. Like, by number properties, kind of, because again, you could think of it as a negative number times something is positive. It's got to be another negative number. That's the only way that like two numbers will multiply to a positive, is if they're both positive or they're both negative. And since we have a net -3v there and it's coming out positive, they have to both be negative. Actually, cool with that though. Like, that v being negative is the important thing there.
Okay. So that's why it flips?
That's why it
That's why
flips.
it flips. Okay.
That's why it flips is exactly right.
Oh, because we
So
know, okay, I get it, because we know V is negative, so that's why
because
you
we
have to
know
flip
V
it.
is negative is
Okay.
exactly right. And that's also why when we were talking about C, that's why when we divided by a minus V, that minus in front of it turns it the other way. It's like a switch flipper, right? So we know V is negative, minus V then is positive. It's the opposite. Um, and so, yeah, that's why C was the most vicious of all the answers. Terrible answer. Luckily, I've got another one lined up that plays on this, but in a less complicated way. How ready do you feel? If you're ready,
Almost ready. One quick
tell me.
question.
Yeah, please, please.
On C, why did we not get the answer choice C? Why did we not get the sign change?
On answer choice C,
Yes.
exactly because of that. So the difference between B and C is really at the heart of this whole thing, right? When we in B, what we're doing is dividing both sides by an answer choice B and getting the answer choice B, what we're doing is dividing both sides by V, right? And because V is a negative number itself, like inherently a negative number, there we go. Um, we have to flip that
Oh yeah, that
inequality
was the
sign.
negative and the negative and
Mm-hmm.
the positive. Okay, sorry.
Exactly.
I
Yeah,
blinked out
yeah.
on that one.
No, no, no. It's totally fine. It's totally fine. I'm glad you asked. All right. We're gonna have another chance though. And again, in like I will say, that was a pretty hard problem. That was a pretty high level problem. Hey, you should be like proud. This one is just one level down, but they're still both, above the 600 level. So take a look at this one and see what you can work out real quick before we talk about it. All right, so thoughts. What are we thinking?
I'm not sure. I'm thinking B, but that seems too obvious.
But you see where the 1/4 comes from, essentially, right?
Yeah.
Yeah. Good. Good, good, good. That means you're on the right track. And that's like, that is important. It's like, it's always one step at a time with these. And this is why it's a good idea to do targeted practice, like a bit, because you can do a problem that has everything in it. And if you're getting one thing from that problem, you're ahead, right? But it's hard to get everything from every problem you see and then like apply it perfectly to other problems. There's like some growing pains on it. So, all right, let's figure this out. It's all about, again, connections, right? Between one thing and the other thing and the other thing. So we've got this fact about Y, then we've got this kind of big thing about XY, or sorry, for X and Y. And then they ask us about x over y. So what we're trying to get to, our goal is that, right? X over y. And we want to know something about that. And you can kind of see that it's got to come from this because that's the only relationship that puts x and y together. And you can probably see how you get to x over y. You'd have to really divide the y over to put it under the x or something along those lines, right? But you've also got this thing, which is obviously connected in some way to that. It doesn't tell us anything about x, and so it can't really give us x over y in any meaningful way, but it tells us something about y, and especially if we're thinking about dividing both sides of that middle thing by y, we really do want to know its sign, right? Like that's always the danger when you're dividing both sides by a variable. Do you know its sign? Are you safe? Or do you need to flip the inequality? Or do you not know and you'd better not do it? And so that's why they're telling us that, right? Remember, everything they give you, it's there for a reason, right? There's a why behind all of it, and its reason is going to be seen in how it like connects to the other pieces of the puzzle. So knowing that y is negative then means that how do we actually have to go about this math here? We're trying to get to this goal, right? X over y and something about it. Divide both sides by y. And you'll at least have x over y on the left. You'll have 4x over y, so there'll still be more to do, but you'll have x over y. But you're dividing both sides by something, and it's an inequality. And so your like alarm bells have to be going off because multiplying and dividing, those are the danger points in inequalities. So we got to consider, are we allowed to? Do we know y's sign? Do we know whether we need to flip? And of course, we do. We know y is negative. So if we're dividing both sides by y here, we got to make sure what? What does it come out to then? 4x over y. On the right side, you're going to have 1, right? Y over y is 1. In between, moment of truth, less than. Because y is a negative number when you're dividing it over. Because they told us y was a negative number. Because they wanted us to suffer. This is it. This whole test is just how can we make people have to think too much about something that maybe doesn't matter that much? So get the 4 away from them, and you're going to be getting ultimately to your goal of x over y. You do that by multiplying by 1/4 on both sides. And so there you go. Like you can see in this problem, it's not just about the 1 over 4, but very much about the sign. What is x over y in relation to 1 over 4? Because y is negative, that sign has flipped. And so x over y has to be the thing that's less than 1 over 4. And, you know, actually, even when you had the 1 over 4 in hand, the next level of guessing from where you were at is I got to guess A because this is an inequality, right? Which means, you know, you may not know where the sign was flipping, whether it was flipping, you may not have been sure about that. And so you might have like almost left that blank, right? You know, x over y has a relationship of some kind with 1 over 4. But because it's an inequality, you know it's going to be an inequality relationship of some kind. And so reasoning it out, it's either got to be x over y is less than 1 over 4, in which case you have exactly one answer here, 0, or x over y is greater than 1 over 4, in which case, how would you choose among the 3 answers that would still be remaining, right? And so the next level of that educated guessing is because this is an inequality and it's coming out with x over y and 1/4, there's only one way that inequality could point that would yield a single answer, and there had better be a single answer to a question. Otherwise, what are they doing to us, right? And so that would have been the way to actually seal the deal on that. Like you were very close, and just a tiny bit more, and the like inequalities logic of it could have pushed you over the edge to a right answer. Yeah. How are we feeling about that? I still sense some unease with the fact that like y is negative and so the sign flips, even though it looks really positive.
Yeah, I think that's what's tripping me up is like when do you know when to flip? I think. And it's like, it's confusing because it's like, okay, if it's a variable, it can be positive or negative, but then what you just showed with the last question, that if you know
Yeah,
the variable's negative, then it doesn't flip. Like,
exactly. It's
yeah,
like if it's a variable and they don't tell you anything about it, you don't do it, right? But in both this problem and the last problem, like here they just flat out told you y is negative in the beginning, right? Last problem they made you work for it. That incidentally is what makes that problem like one level above this problem, because you have to work for something that like is still going to be a complicated thing in the like after that, right? Like even here where they tell you y is negative, it's still complicated to actually use it effectively, right? But yeah, the idea is with inequalities, you be careful multiplying or dividing by a variable. You don't do it unless they've pinned down that variable sign for you, right? And so that's how you want to read the fact that they're telling you y is negative. You want to read it as, oh, they've pinned down y's sign for us. So in a like wider inequalities problem, which this is, I can do some algebra with y in a way, like in a responsible way. There's no ambiguity to it anymore. That's the real danger, that a variable, if they don't tell you anything else about it, is ambiguous in value. But if they do tell you its sign, algebraically speaking, you know what's going to happen. And you know, the alternative is this. If they had told us y was positive and 4x was like, let's just say less than y for the heck of it, we could still divide both sides by y here. We just wouldn't flip the sign, right? Because they told us
yeah,
y is positive. And so that's it. Like that's really the only difference. If they tell you y is negative and you divide both sides by y, which you almost guaranteed will in a problem like this, because they want to put you in that uncomfortable situation. They tell you y is negative and you do it, you flip the sign. They tell you y is positive and you do it, you don't flip the sign.
okay, just for clarity.
Mm-hmm.
So if you're dividing by like a number, like an integer that you know is negative or positive, so like let's say you have negative 4x
Yep.
is less than 8 as an
Mm-hmm.
example, right?
Mm-hmm.
And then so you divide by negative 4, you divide 8 by negative 4, and then you still have to flip the sign because you're dividing by a negative number.
Yep.
Okay.
Precisely that. Precisely that. And so yeah, that comes out to x is greater than -2. And again, like when it's numerical like that, just test a value on the flip side and make
Yeah.
sure you know that you've got it. But yeah, that's exactly right. And yeah, when it's a number like that, like look, it's hard enough honestly to remember when it's a number like that because it's just not something you do every day, right? When it's a number like that, though, it's at least like it's wearing its heart on its sleeve. It's a lot more obvious that that's happening. When it's like let's just say it's xy, right, is less than 8 and somewhere they tell you y is equal to -4 or something, but like you know you or let's say it's like that, your first inclination when you see this is just going to be cancel the y's out, right? Like divide the y's out, it's gone, you never have to worry about it. But if y was secretly -4, then what you're doing there is no different from what you're doing over here, right? Dividing by -4. And so you would need to flip the sign, would be the idea. I mean, look, you'd probably just plug in -4 for y in this case, but I'm
Yeah.
just saying, for example. Yeah, yeah,
Yeah.
yeah. I'm just saying, like, for example, if you know that, like, from some other thing that y is a negative number of any kind, right? And you're dividing both sides by this y, don't be fooled basically by the fact that the letter y looks positive because it's got nothing in front of it. Whether y is positive or not depends on the number it represents, right? And that's
Right.
something you'll be getting info on elsewhere in the problem, right? And this is the sort of way they communicate that information to you, or that like -3v is greater than 0 is a way they communicated information about v to you elsewhere in the problem. But yeah, that's the real like tricky part to inequalities, that like negatives make them behave funny and variables which might be negative are danger points. But as long as you're thinking about, hey, could this be negative or whatever in an inequalities problem, you'll at least be like, you'll be showing the right amount of caution, because like I would imagine you're at the point with inequalities at which you're getting them wrong because you're treating them almost exactly like equations. And so you'll like, there will be a trap answer for that, right? If they're testing, hey, does this person know that negative things make this flip? And you don't know that going into an inequalities problem, there's guaranteed to be a trap answer for the person who doesn't know that thing, because like ultimately that's probably the only trap answer that really matters there. That's like the only trap answer that's going to get people. And so like that might be a little bit where you're at with inequalities. And I'd say like go back through that last practice test, see some of the ones you got wrong, and see if it did really boil down to that, or you know, goodness forbid, something else. But yeah, this is kind of at the heart of most of them.
Will the question always give you that piece of information that tells you whether or not it's positive or negative,
No,
like the why? No, okay.
no, especially if it's like data sufficiency, then no, then that'll be part of the like challenge of the problem. Maybe they'll give it to you down in a statement rather than in the question stem, for instance.
Right.
And even if it's something like this, they could just as easily have not given you that, but the rest of the question would have to change actually. They'd have to say like if 4x is greater than y, which of the following could be true or something like that. And then it would be like a could be true answer because you don't know a lot for sure about what's going to happen when you move y around is the truth of it. So like yeah, it's or they might ask which of the following must be true and then have trap answers that have you dividing by y and stuff like that. And you can't say anything like that if you don't know y's sign. So no, they won't always give it to you, but the ending of this problem would have changed if they hadn't given it to you. The ending of this problem could only be asked the way it was because you knew y's sign in this case. Um,
So it's kind of like I think I don't know. My takeaway is like I should always look through the question to see if there's any piece of information that will tell me. Like you're right, whether it's in the question itself or in one of the possible, like in
mhm,
the answers or something.
mhm.
Okay.
Yeah,
Yeah.
yeah, exactly. Like you shouldn't feel as free to do algebra on an inequality as you feel in an equation because there are restrictions. Two,
Right.
those restrictions are largely going to be around variables and operations of variables, multiplying and dividing. And then three, you should always then be looking for other information in the problem that like either gives you the sign of the things or, if nothing else, look out for other things in the problem that are trying to prey on you as though you know the signs of the things. Like yeah, it's basically always about the ambiguity of variables and the numbers they represent, the positivity or negativity. So, um, yeah, yeah. Any other questions on this one? All right. Sounds like something terrifying is happening outside in my house. So I'm gonna call it there. I'm gonna call it an hour at this point, you guys, and go see why people are literally screaming here. But there's my email address, like last time, like always. If you have more questions on inequalities or just anything, of course, you guys email me. I don't know who's doing the next free prep hour, but you guys are always welcome. Please come back and it was nice to talk to you.
Okay, thanks so much.
You're welcome. It's nice to see you too. It really was nice to see you again. Keep coming, Ashley. Like, take full
Yeah, for
advantage,
sure I
please.
will.
And to you too. I say not to not include you. I say just like keep coming. Like you're most welcome. All right. See you guys. Oh, sorry, I didn't put it in the public email. Here it is. Yep. See ya.